This video is over lesson 95, slant heights of pyramids and cones, and it is for my pre-algebra classes. So, first of all, little terminology. For pyramids and cones, this top point of a pyramid or cone is called the apex. The polygon across from the apex is called the base. So pyramids have some sort of a polygon. Sorry, I misspoke. Pyramids, it's the polygon across from the apex. For a cone, it's the circle across from the apex. So apex, base. The height of the pyramid or cone is the distance from the apex perpendicularly to the base. And so we typically draw that in most of our pyramids and cones, especially the ones we're going to be dealing with. If they're set up like this, it's going to be just going straight down to the center of that base, so that polygon or that circle. So straight down, and we see a little right angle symbol there to say it's perpendicular to the base. So a slant height, on the other hand, as it kind of implies, it slants. It's not going to go straight down when it's oriented like this. A slant height is the distance from the apex perpendicularly to the edge of a base, to an edge of the base. So your book actually describes it as going along the surface instead of the interior of the figure, the surface of the figure. So for a slant height, I might draw a slant height in by starting at the apex and going like this down to an edge and then marking that as perpendicular. In a cone, I would just come kind of down here like this to the edge, and then again mark it perpendicular to that edge. So that's typically how we draw a slant height. Now, ladies and gentlemen, in a little bit we're going to be asked to actually find the slant heights of a few figures, and so it can be helpful to understand the cross section of these. So the cross section, imagine you were to line this up so that this side of this face of the pyramid was facing you, and then just cut straight down. And you were to open it up and look at what you just cut open. That's a cross section. So same thing here. And it turns out with both a pyramid and a cone, if we cut it up like that, we'd basically get a triangle for our cross section. And so this right here would be the height of that pyramid or cone, whereas this outside edge would be the slant height. And what's going to be very convenient for us in just a moment here is that since this makes a right angle with the base, what we end up with is basically two right triangles. And, well, as we know, right triangles, A, B, C, A squared plus B squared must equal C squared. So with those basics out of the way, we're going to go ahead and look at the practice problems for this lesson. I'm going to flip to the back here. So grab your books, and we're looking at page 636. 636. Letter A. Describe the difference between the height of a cone and its slant height. So the difference is, well, first of all, let's start with how they're the same. So both are a distance from the apex, but height is perpendicularly to the base, whereas slant height is perpendicularly to an edge of the base. So it's just a matter that you're still going to make a perpendicular measurement here. You're still going to make a measure that out. But where are you going to? Are you just dropping down to the base, or are you slanting over to the edge of the base? That's the difference. B, compared to the height of a pyramid, the slant height of the pyramid is, well, if you can't just go straight down, you're going to have to go along the outside edge. It's going to be A, longer. Going around the outside is longer than just going through the center. And C. So for problems C and D, find the slant height. Sketch a right triangle to show the dimensions you used for your calculations. So basically what the directions are asking for are the cross section. So for letter C, we see that pyramid. It's a square pyramid, so it's got a square base, 8 centimeters by 8 centimeters, and it has a height of 8 centimeters. So it looks like that was carved out of a cube. So the slant height here then is going to be, or it's going to be the cross section, might look something like this. And so this would be 8 centimeters down here. This would be 8 centimeters for the height. And now a squared plus b squared plus equals c squared, so Pythagorean theorem. The one thing we do need to keep in mind here, though, is if this is 8 centimeters all the way across, is this triangle going all the way across? No, it's not. It's only going halfway. So that means this edge here is actually only 4 centimeters. So when I use my Pythagorean theorem, this is going to be 4 squared plus 8 squared equals c squared. So be careful about that. If this goes 8 across, you're only using half of it. So 4 squared is 16. 8 squared is 64. That equals c squared. 16 plus 64 is 80. And now if I take a square root of both sides, and remember here, because this is a real world problem, can we have a negative for the length of that third side? No, which is why we don't have a plus minus over here. All right, so to finish this off then, I'm going to just flip this over and have my c over here. And then I'm going to think about, can I reduce that radical? So square root of 80 is irrational, but can we simplify it? Is there a square that goes into that? And yes, there is actually. 16 goes into 80, and it goes in 5 times. So this is really 4 square roots of 5, and then the label, centimeters. 4 square roots of 5. So that, ladies and gentlemen, would be the exact answer. The exact answer. Now, if we want an approximate answer, just grab your calculator and type in 4 times the square root of 5. And so you could find an approximate answer of, and so we say you have 2 decimal places there. Let's go 2 decimal places here. So 8.94 centimeters. I guess we didn't have 2 decimal places. Let's just go 1. Let's go 1 for this. Since everything was whole numbers, we'll go 1. 8.9 centimeters. And that's all there is to it. Let's do D. So my cross section here, the cone is flipped upside down. It's more like an ice cream cone right now. So I'm going to put that longer part, or that flat part up top, and that's my 4 inches all the way across, and it's going down 6 inches. So that means that this height in here is going to be 6 inches. And again, remember, ladies and gentlemen, if 4 inches goes all the way across, then we're only using half of that in the triangle. So 2 inches will be in the triangle. So my Pythagorean theorem here is going to be 2 squared plus 6 squared equals c squared. So 2 squared is 4, 6 squared is 36, and then c squared. And then go ahead and add those up. So 40 equals c squared, square root of both sides. So c therefore equals, and I'm looking at that and I'm thinking, okay, what perfect square goes into 40? Well, 4 does. 4 has a nice square root. And then c then will equal 2 square roots of 10. Any more perfect squares that go into 10? Well, no. So throw our units on now. This was inches. So that is my exact answer. If I do 2 times the square root of 10, we can find our approximate answer, which will go to 1 decimal place again, so 6.3 inches approximately. And that, ladies and gentlemen, is the end of our lesson.